just after noon on July 10, and I have just completed what we call the noon shot for Latitude, and I thought I'd talk about it a little bit. Every day that we have sun, even if it's veiled by cloud, as long as I can see the orb of the sun, at noon we come on deck and we shoot the sun, and I promise we don't do it anymore. We shoot the sun at noon to help us figure out where we are latitudinally on the globe. To do that, I have to know what time noon is. And noon is not actually clock noon, watch noon. Noon is actually a derivative of exact noon at Greenwich, England, at the Royal Observatory actually. Where time is concerned, everything starts at Greenwich. So if you, for example, wanted to know what time local noon was at your location, you could go online and look up what's called the Meridian Pass. And then you would add to that your longitude and subtract out where you are relative to Greenwich, and that would be your local noon. I can't do that. I can't get online, but I have an excellent book called the Nautical Almanac, which carries in it all kinds of time-sensitive data that we need for navigation. So in the Nautical Almanac today, I looked up July 10 and found that noon at the Royal Observatory in Greenwich, England was 12:05. I know that I'm roughly at 140 degrees west longitude, and as you know, all I need to do is multiply my longitude times 4, because there are 4 minutes in a degree of longitude, and that gives me the number of minutes from 12:05 until it'll be exactly noon here. And that all turned out to be 11:25 this morning Hawaii Standard Time. So at 11:20 or so, I came on deck with my sextant and started measuring the sun, so that right at 11:25 I knew I had it. So this is what we use. Sextant, meaning 1/6 of an arc, 1/6 of a circle actually. And all this device does is measure the distance between a body, say the sun, and the horizon. It does that by letting you look through an eyepiece here that shows you the horizon, and by using a set of shades, you don't look directly at the sun. By using a set of shades, you can actually also see the sun. So I point the sextant at the horizon. I what we call pulling down the sun. I pull down the sun using this measuring arm here. I pull down the sun until its lower piece, called its lower limb, is right on the horizon. And when I've got the sun perfectly balanced right on the horizon in my eyepiece, I stop. Sometimes that can be a real trick when it's rough or when the sun is not very distinct. Sometimes it's a little bit of a guess. A couple of the shots I've done over the last few days, I couldn't actually quite see the horizon because it was so gray. So sometimes it's a bit of a guess, but on days like today where it's just brilliant out, the horizon is incredibly sharp, the sun is very bright, you get a really clean, easy shot. So you bring the sun down until the superimposed sun in the image is right at the horizon, and when you get there, stop, and you've got your measurement. So today, my measurement, interestingly enough, at local noon, the sun was 55 degrees and 59 minutes above the horizon. So not straight up, but only about 60 degrees up. Interestingly, when we left Hawaii and I started taking sextant shots for noon sites, what I found there was that Hawaii was at that point almost exactly below the sun. It was almost 90 degrees. The sun was almost 90 degrees above the horizon at noon. And that kind of surprised me at first because Hawaii is not on the equator. Hawaii is at 20 to 23 degrees latitude, north latitude. So why would I have such a clean angle? And the reason I finally realized was because the Earth is, as we move into summer, the Earth is tilting the northern hemisphere closer to the sun, and that process takes us to about 22 degrees of declination, which is also roughly the latitude of Hawaii above the equator, which is why the angle was so big. So there, the sun was almost directly above us when we left Hawaii. Here, where the sun almost never sets. It also never gets very high. It's only 60 degrees roughly above the horizon today. So that was my shot for Latitude today. Do that every day. And the result was that, and also interestingly today, this is also very rare, the measurement that I got, the degrees of distance, angular distance of the sun above the horizon, was almost exactly our latitude. We're at 56 degrees north today, 140 west. We are 157 miles from Sitka. We should arrive in the next couple of days. And as seems typical now for me and passages, the closer we get to a location, the closer we get to our goal, the slower we get. Today, as you can see, is gorgeous, but there's almost no wind. 5-6 knots from the south-southwest. I have everything up today. Everything I can fly, and it doesn't matter what the angle of the sail is to the wind, just get it up there, because you got to catch some wind. Right now I think over the ground, over the water I should say, we're making something around the range of 4 knots, which is actually pretty good, and I shouldn't complain. But I get so impatient at this part of a passage. We're so close to reaching Sitka, and I can't get there if the wind doesn't blow. I have to sail every last mile. I can't swim. So I'm trying to find jobs. Measure the sun, measure it again. Cook a nice dinner, clean up below, do something, listen to music, sing as loud as you can, but keep busy, because these last couple of days are always the hardest. It's kind of too bad because it's just absolutely gorgeous out right now. Probably you can hear in the background the jib and the main kind of banging around. It's called slatting, when there isn't enough wind to fill the sail and it rolls, the boat rolls and the sail moves in the wind without being full. It's called slatting, and it's an unfortunate sign that we're not going very fast, but we will get there. Sitka is close, 157 miles. I would anticipate that we will probably arrive tomorrow evening at some point. There are only about 2 hours of dark, and I think actually that's when we'll arrive, strangely enough, but we'll see. And so that's my report for the day. I just wanted to give you a sense of what it was like to work with the sun to find our location.